Okay guys, today we are going to talk about classifying rational numbers along with comparing and ordering. But comparing and ordering, you kind of already know that and know how to do that. So I'm just going to kind of add a little tip to that at the end of this. But you should have this little wonderful little guided note sheet. Looks like this, okay? And we're going to start down here at the examples. Okay, so let's begin with what is classifying. Classifying is like putting things in a certain category. So, for example, if you have some children with brunette hair and blonde hair and red hair, classifying them would be you would have redheads, and then you would have brunettes, and then you would have blondes. That would be classifying. Okay, and a lot of people use classify the relationships between the sets or each other by using a Venn diagram. So right here, I did not actually put this down for you. So I want you to write down what a Venn diagram is. A Venn diagram is a diagram, okay, using shapes. So, for example, like this square and then the circle one over here. Using shapes to show the relationship between a set. Okay, so that being said, let's start with an example of how the Venn diagrams work. I know you've probably seen them before in the past. But just real simple, like one this and this. But now we're going to talk about how they work and how they come together. So for the first one down here at the bottom where it says an example, okay, we're going to talk about animals. Okay, well, animals, let's think about what involves animals. Animals can be pigs, animals can be cows, horses, cats, dogs. I mean, there's numerous kinds of animals, all kinds of animals. Okay. But if I wanted, so this would be all. So this is everything, okay? Where here, we're going to talk about just dogs. Well, that breaks it down. Now we're talking about, well, yes, a dog is an animal. That is true. But we're specifying dogs. Well, there's all kinds of dogs. There's bulldogs, there's pit bulls, there's labs, there's Dobermans, there's tons of dogs. But we're going to talk about one breed, and that would be pugs. Those are my favorite. So, again, we've gone from, well, they're animals, okay, and a dog is an animal, and a pug is a dog. So you see how they work together. So animals includes all of this, okay, and then dogs is an animal, yes, okay, and pug is an animal, but a dog is a pug. A dog can't be like a cat or, a horse or anything. So it goes animals is everything. And this is just the one kind of animal, which is a dog. And then this is a breed of a dog. So you see how you work your way out. So a pug can be a dog, and a pug can be an animal. See that? But a dog can be an animal, yes. But a dog can only be a pug. So I hope we understand how that works. So we're going to start talking about, different kind of classifying rational numbers. Well, we need to know what each thing is. So let's start with, well, what is a rational number? Hopefully by now you do know this. So a rational number, okay, are all integers, so integers, and fractions, and decimals. So all integers, fractions, and decimals. Every rational number can be written as a fraction. So A over B, that's a fraction. Okay, and AB being integers. Okay, some examples. So we have 3 over 5, that's a rational number. Negative 0.175, well, that's a decimal. And then 7/6. These are examples of rational numbers. Okay, rational numbers can be integers, fractions, and decimals. So integers, fractions, and decimals. Okay. Now, here we have integers. So integers. integers are positive and negative whole numbers and decimals. That is incorrect. Sorry, whole numbers and zero. Whole numbers and zeros. Fractions and decimals are not integers. Please remember this. So no decimals or fractions can be as an integer. Examples of integers are like -4, -2, 0, 2, 4. These are integers. That's what goes here. And if you want to put it in here, you can. And they can go wherever, wherever you want it to go. Alright, and then again, rational numbers are fractions, so 2/3, -1/4, 0/75, -0/75. These are all, this is everything. It's integers, fractions, and decimals. Like we said about the animals, this is everything. This is a specific rational number. Okay, so integers. Now, whole numbers, okay, whole numbers are all and only positive numbers. Positive numbers including 0. Okay? Negative numbers are not considered whole numbers. So right here put no negative numbers. I'm just abbreviating that. So examples would be like 0, 1, 2, 3, 4, 5. Okay? So 0 up. Only positive numbers. And you can put some examples in here if you want. Okay? So this is another Venn diagram, and you might see it this way. It's the exact same thing. It's just in the shape of a square instead of a circle. So your whole numbers goes here, integers goes here, and rational numbers go here. Okay? As you grow in your math, you'll also learn about other classifications of numbers, like irrational numbers and stuff like that. But right now we're just going to work with whole numbers, integers, and rational numbers. Okay, so now what I want you to do is I want you to flip your page over, or you can just bend it like this, however you want to do it. Okay, and we're just going to talk about comparing and ordering. Okay, comparing and ordering. Now you might do this on a number line. You might do this just by least to greatest, greatest to least, whichever. So, for example, if I had 3 halves, 0.5, -1, and 3. And I said, okay, well, let's put these in order. Okay, so, well, this case it would be order, and let's put it in order from least to greatest. Well, our least number is going to be negative, of course. So our negative is what? -1. Okay, so the next number, well, you need to find out what 3/2 is. So you can do top in, bottom out, and divide that like this. 2 goes in 3 one time. Bring down a 1, that's a decimal. Now that's 5. So we know that this is 1.5. Guys, anytime you're comparing and ordering numbers and you have a fraction and a decimal or a fraction and a whole number, turn it into decimals. Always turn your fractions into decimals. It helps you see which is bigger. So if that helps you, just always remember that, okay? So next would be what? So, well, 0.5 is smaller than 1.5, so we'll put 0.5 here. And then it would be, well, 1.5. And then it would be 3. So this is in order from least to greatest. Now you also might see it like this, where you might have -2.8 with a little slash like that, and maybe like -2.9. And it'll say, okay, well, you have your greater than, less than, and equal to. Those are called inequalities. So you need to look at this and be like, okay, well, which one is -2.8 greater than -2.9 or less than -2.9? In this case, if we're looking at a number line, okay? And we're just going to look at it this way. If I'm going this way, remember this is less than. So my bigger number is further away, which means it's going to be smaller. So negative 2.8 is actually greater than negative 2.9. Because let's say 2.8 is here and 2.9 is here. Well, which one's greater than? The one that's closer to 0. So that would be this one. So negative 2.8 is greater than negative 2.9. You also have it with integers. You know, they'll have it like this, where you have negative 3, negative 12, 10, 15, and 0. And they'll say put it in order from greatest to least. In this case, that would be 15, 10, 0, negative 3, and negative 12. So this is just a way of comparing and ordering integers. Same thing, it would be like negative 3 and negative 2. Well, which one's greater than, less than, or equal to? Well, negative 3 is less than negative 2. Alright, if you have any questions, please feel free to ask your teacher. Otherwise, you can go ahead and move on to the practice for all of these. Again, have a good day and good luck.